Oh yeah, look at those salts. Oh, the potassium chloride. Oh my god. Oh, hello there. My name is Akbar, aka Slim Shady, and today we'll start a new project on YouTube. My team, which consists of Xeonian Stranger, Vertex J, and Swag2K, will bring you chemistry-related videos. Today we'll cover a very important topic: salts. Salts are everywhere, in the ocean, in your cells, in your food, and even in your mom.
And now I know my heart is a ghost town.
First of all, to know what salts are, we have to know what ions are. An ion is essentially an atom which has lost or gained electrons. The number of electrons can of course vary. It could be either one electron gained or lost, or a couple. Now when an atom receives an electron, the number of electrons outnumber the number of protons. This results in a negative charge, and the atom becomes an anion. The same thing, but the other way around, happens when an atom gives up the electrons. The protons outnumber the electrons, and the ion is positively charged and becomes a cation. This is because every atom wants to become an octopus and have 8 electrons in their outer shell. This is the octet rule. Now it is important to remember that ions can have different charges depending on the amount of electrons that they gain or lose. Chlorine, for example, gains 1 electron and also gains 1 negative charge, whereas oxygen gains 2 electrons and acquires 2 negative charges. The same concept applies for cations. We have potassium, which loses an electron and gains 1 positive charge, and we also have calcium, which loses 2 electrons and gains 2 positive charges. Now that we have ions out of the way, let's talk about salts. In the most general sense, salts are crystalline compounds that are composed of anions and cations. It is important to remember that salts are always in a neutral state. Therefore, the charges in the salt equal to 0 if they are added together. Let's take a closer look at sodium chloride, more commonly known as table salt. Sodium chloride contains a positively charged sodium ion and a negatively charged chloride ion. Added together, these two charges equal to 0. As a chemical formula, you simply write NaCl, due to the fact that the charges balance each other out without the demand for another ion. To make this concept a bit more clear, here's magnesium chloride. The magnesium has 2 positive charges and the chloride just 1. Now we want you to figure out this one for yourselves. Pause the video and try to do it, then check your answer with ours. How would you write the formula? Because you need the charges to equal to 0, in the end you need 2 chlorides to equal the 2 plus charge of the magnesium. Thus, as a formula, you write 2 after the Cl as a subscript to show that you need 2 chloride ions, MgCl2. Great, now you have a basic understanding of both salts and ions. We can take a closer look at salts, their characteristics. One of the most important being their crystalline structure. Let's take sodium chloride one more time. The ions and salts are bonded in such a way that they build up a steady grid structure in which the ions are packed closely to each other. This type of structure gives salts most of their properties: an ability to conduct electricity, brittleness, and high melting points. The reason why salts cannot conduct electricity in a solid state is because the ions are fixed in the solid grid structure. The charge carriers in the salt are not able to move and thus cannot carry charges around. The high melting points also come from the grid structure. The bonds between the ions, ionic bonds, are very strong and thus require a lot of energy to break. So, you need a lot of heat to actually break those bonds. That is all that we'll cover about salts. Anyways, let's summarize what we learned today. First of all, we talked about ions and the different charges they can have. In addition, we also talked about salts and how to use ions to create a formula for salt. Lastly, we talked about some of the important characteristics of salts: an ability to conduct electricity, brittleness, and as well as high melting points. Thank you for watching this video, and remember, stay explosive.